right, welcome everybody. Today, I'm going to talk to you about the most exciting topic in the world, which is data validation and sanitization. I know you were all just chomping at the bit to hear about this, but hopefully I'm going to frame it in a way that maybe makes it a little bit more interesting and exciting, but we'll see. So first, just a little bit about me. I am a data engineer at Purdue University in Indiana. I added the Indiana part of that just because nobody seems to know where Purdue is actually located. I've had people tell me Washington. I've heard Washington, New York, and Pennsylvania so far. So come up to me after the conference if you thought it was in yet another state, because I'm keeping a tally. So yes, but it is in Indiana. I am a huge data and analytics nerd, I have a shirt. So yes, data nerd. And I'm also a sci-fi nerd, so talk to me about sci-fi as well. Star Trek, Doctor Who, whatever. I was also a member of 100 Devs Cohort 2. Yeah, woo! Do we have 100 Devs folks in the house? Let's go! Sorry if I blew out the mic there. I'm a Twitch streamer, I gotta yell, right? But yeah, so I was a member of 100 Devs Cohort 2. It was a really wonderful experience. So wonderful to see so many 100 Devs folks here in the audience and online. I see you out there on Discord. Thank you all for being here. I also stream online, create content online, I guess, as Mayan Wolf. I'm pretty much Mayan Wolf on all socials. So if you want to find me on social media, any social media, look for Mayan Wolf. That'll be me. And some people have asked me, where did the username Mayan Wolf come from? Well, sometimes you're 13 and you come up with a username that you think sounds super cool, and then it follows you for the rest of your life. And that's just how life is sometimes. All right. In addition to all that, I'm also a Pilates instructor, and I have a dog. Now, that's not my dog in the photo. That's an elephant. Just so we're clear. All right, but let's get into the actual content here. So what are we talking about today? There's a property called the infinite monkey theorem. Have you ever heard of that? Yeah, several of you have. So essentially what it says is, and this is the photo from the Wikipedia page, which I really love. A monkey hitting keys independently and at random on a typewriter keyboard for an infinite amount of time will almost surely type any given text, including the complete works of William Shakespeare. Now, equivalently, enough users interacting with an application over time will almost surely enter something into an input form in a way that was not intended by the developer. Now, I am not calling our users monkeys here. I am just illustrating the probability, right? This is a probability. If you let anything go on for an infinite amount of time, you are going to end up with something you did not intend, right? If you let people interact with your app over the long term, you're going to end up with something you didn't intend. So how many of you have ever designed a user interface? Yes, almost all of you. How many of you had that UI end up being used in a way that you did not intend in your design? Okay, almost all of you, yes, right? It happens, right? And there's really no way to prevent that from happening. Stuff is gonna happen. People are gonna either not pay attention to how a form is supposed to be used, or you're gonna have malicious actors coming in. You're gonna have bots. You're gonna have people trying to steal the information that is contained in your application. We can't prevent that 100% of the time. But what we can do is attempt to protect our applications against unintended or malicious data entry using data validation and sanitization methods. And I'm going to define those. We're going to talk about more about what those are as we go on. But first off, I want to kind of frame this with something, a visual aid. So I'm going to use Bobby tables. Have y'all heard of Bobby Tables? Who's a fan of Bobby Tables? Yes. All right. So very famous webcomic, XKCD. If you haven't heard of XKCD, go check it out. There's an XKCD for literally everything you could ever think of related to tech and beyond. But this XKCD was number 327. It was published in October 2007. So almost 20 years ago. Criminy, I feel old. But yeah, this was published in 2007, but it is still just as relevant today. So I'll go ahead and just describe it verbally. A woman is on the phone. Someone is telling her, "Hi, this is your son's school. We're having some computer trouble." She says, "Oh dear, did he break something?" The school person says, "In a way." They say, "Did you really name your son Robert, single quote, parenthesis, semicolon, drop table, students, semicolon, dash dash?" And she says, "Oh yes, little Bobby Tables, we call him." And the school person says, "Well, we've lost this year's student records. I hope you're happy." And she says, "And I hope you've learned to sanitize your database inputs." Yes, so classic, and it's just as true today as it was back 20 years ago. Now, you might kind of understand this on like a conceptual level. Like, yeah, she did something, super clever and it broke their application. But do you really understand the whole strata of what happened here, right? There were multiple points of failure that got to the point where they lost all of their year's student records. There were multiple points where this could have been prevented on the front end, in the middle, in the database, everywhere. And they apparently had none of those points of protection. So we're going to talk about that. We're going to kind of analyze this a little bit, understand what happened, and understand all of the points where this could have been prevented. So first off, what actually happened here? So at some point, the mother was given access to an input of some kind, probably an online registration tool, register your kid for school online, or, sign up for our school newsletter or something like that. What's your kid's name? So there's a form asking for a name. And given that it's a name field, it was probably free text entry, right? You just put whatever you want in there, it's gonna be fine. We don't know how long people's names are, so we're not gonna put any limits on character length, all that good stuff, yeah? So she entered that phrase, Robert dropped table students, into a form with insufficient validation. So there were no checks on that entry to say, hey, is anybody gonna try to do something fishy here? Is anybody gonna try to put something in here that maybe isn't a name? And so after that data was allowed in with absolutely no checks, the data was taken in by the application and it was processed. The application was like, yeah, I'm sure this is fine. No, nothing wrong here. And it was not sanitized at any point. So at no point was this entry checked to say, hey, are there any maybe bad characters in here? Are there any characters in here that could maybe cause a problem downstream? Maybe a database might not like some of these characters or might think that they're, something that it might have to do something with. Nope, none of that. This was set right through. And then it was stored in a database, right? And there were no checks at the database level either. The database was like, yeah, sure, fine. I'll just, I'm just a receptacle. I'll just, take this, whatever. And then after that, the data was stored in that database and it was in there like a ticking time bomb. It didn't really cause any harm while it was just in a database table. It's just fine. It's just sitting there. But then at some point, some poor school administrator sitting in the office just wanted to pull a list of all the students that they were going to send a newsletter to, or, get them to print out the forms to sign up for the field trip, do a mail merge, whatever. So they signed into their application. And they said, hey, get me the list of all the names in Mrs. Hammond's class or whatever. And when they did that, the application executed a SQL query against the database. And it was meant to be a read-only query like the one I have there in step 3, which is select star, which if you're not familiar with SQL, that just means give me everything. Select star, give me everything from the table called students, where the name field is in a set list, or it could even, it could have been, had different filters or constraints, or, where student in Mrs. Hammond's class or something like that. But this is just for illustration purposes here. So where name in Amy Pond, Bones McCoy, it was expecting something like Bobby Tables as just a plain old string name, Arthur Dent. But what it gets instead is 2 statements and a comment. So how that breaks down, it's still select star from students, but then it becomes where name in Amy Pond, Leonard McCoy, and then the malicious phrase that mom inserted, which causes the name list to end. So we close that string on Robert, we end it with a parenthesis and a semicolon, and then we start executing another statement. And that statement is drop table students. So if you're familiar with SQL, what drop table students does is it basically blows away the entire students table. And that includes all the data in that table, as well as the table structure itself. So that table is gone. That table is gone. And unless the school has, good backups that they're taking daily or more often, you're not getting it back. And my guess, given the fact that they didn't have any validation or sanitization in their app whatsoever, probably not. That table is probably gone. So they're going to have to go back to the written ledger for the time being until they can rebuild it. So we drop the table. And then after that, nothing else matters. That's all mom wanted to do. And so anything after that is commented out with a dash dash. So the rest of the statement doesn't matter. It's not going to get executed. So we have dropped that table and it's gone via malicious SQL injection. That's what we call SQL injection. When you are literally inserting a SQL statement into an application via a method basically via an outside method, via user input. You are inserting that SQL statement in, it gets executed, and it does bad things. It might not always be dropping a table. Sometimes it might be fetch me everyone's passwords, right? And if you can do that, you're probably storing passwords in plain text, and then you end up with whoever it is ends up with a text file of everyone's passwords, right? So that's what happened here. That's just one of the ways that people can misuse a form. Now, usually it's not this malicious, right? But have you ever seen a form, for example, where you're meant to enter a date and you're entering that date, and as you do, your cat walks across your keyboard, and all of a sudden you're entering data in the year 3000. And that's actually what happens to me a lot at work. I'm a data engineer, I work with data, and a lot of the data that we work with is not good because we often don't have control over our input sources. As a data engineer, I'm often getting inputs from external sources over which I have no control. I don't own them. I can't maintain my own front end. We have to rely on, inputs created by other people. And oftentimes there are no controls over the length or the sanity of those inputs. So, we're looking at financial records from the year 3000. And I don't know about you, but I'm not living in the future just yet. So, what is validation and sanitization, and how can it help us in those sort of benign situations where someone makes a genuine mistake, and the malicious situations where someone is trying to harm us or dox our users or do something bad or unorthodox or unauthorized to our application? So prepare your retinas for this next slide because it's very yellow. Enjoy. All right. Validation and sanitization. The yellow is going to make you remember it. So what is validation? Validation is kind of like the gatekeeper of your application. It's going to ensure that only properly formatted data enters an application's workflow. So ideally, you want to implement validation as your gatekeeper. You want to implement it before the data is even processed. So at the entry, you don't even want to let that bad data get into your app, because the minute that bad data gets into your app, it can start doing stuff. Malicious JavaScript gets into your application, it can start executing immediately. It doesn't have to make it into the database. It can get into your client-side JavaScript, bam, you're done. So validation is going to ideally be implemented before the data is processed. There's a couple different types of validation that we can use here too, and they're going to work together. So when you're implementing validation, think about these two things. First, we have syntactic validation. It ensures that we are enforcing the correct syntax of our structured fields. And that's kind of, word jargon there. So let's simplify it down a little bit. Let's think about an age field. You want someone's, filling something out. I like to think about maybe you're like, signing your dog up for a doggy birthday party, and everybody needs to know the ages of everybody's dogs. So you're putting in the age of a dog. So if I want to set up an age field, I'm going to want to make sure that that field is limited to only numbers. Ideally, only whole numbers. Because if you think about it, people could abuse that field in a lot of different ways. They could say, they could type the word, if their dog's 4 years old, they could type the word 4 in letters, right? They could put their dog's birth date. They could say, I do not wish to say, if they want to hide how old their dog is, right? So they could do a whole bunch of different things to that form that you didn't intend. So you want to ensure that it's only whole numbers, right? And then the second part of that is that you want to ensure that whatever whole numbers are entered into that field have the correct values given the business context. So if I'm creating a form for a doggy birthday party, I probably only want a certain range of numbers in that age field, right? Unfortunately, dogs don't live forever. We wish they did, but they don't. So we probably want to set a set limit on that age field. Otherwise, you're typing in your dog's age and your cat walks across the keyboard and suddenly your dog is 3,000 years old. My dog is not Anubis. He's not from ancient Egypt, so probably not that old. So we want to make sure that it makes sense in the given business context. So you're thinking about two things here. Syntactic, which is going to kind of be a hard sort of type limit on your form. You're setting some really hard limits just around type. But with semantic, you're also saying, okay, how is this field going to be used? And you better know that if you're setting up a form. You shouldn't just be collecting data for the heck of it. You better know how that data is going to be used. So within that, you can set additional limits on the semantic validation for that particular field. And then next up, so how do we then say, okay, I want to set those limits, but how do I do that? And so when you're thinking about this conceptually, you want to think about what values do I want to allow into this field rather than what values do I want to deny. So going back to our example of the name field, you might say, okay, well, let's scroll back to that really quickly here. So Robert, single quote, parentheses, semicolon, drop table students. Okay, what if I got rid of dashes? What if I just said, I'm not gonna allow any dashes in my name field? It's punctuation, I don't need that. I'm just gonna deny dashes. Okay, that's potential. I could do that. I could write some regex that does that. I could also say, I don't want single quotes, because that would prevent that string from being closed, and then it would, stop this from being able to execute the way that's, the way mom is trying to do here. I'm just gonna not allow single quotes. Yeah, I could do all those things. But then what if someone's name is Sarah O'Brien-Nunez, right? I need to think about, if I do that, and I don't allow single quotes, and I don't allow dashes, suddenly this person, whose last name is O'Brien, they decided to hyphenate their name when they got married. Suddenly, their name doesn't make sense anymore if I'm disallowing those characters, because they can't type it in. They would have to really modify their own name if they tried to type it into that field, because it wouldn't allow those values to be entered. Same with special characters, right? Letters with accents, letters with tildes and accents and all these sorts of things. If I'm trying to make a whole long list of things I want to deny, that can quickly become both confusing for the users and for the developers, hard to maintain, and it could end up with unintended consequences, people not being able to use your app in the way you intend. So what's the better thing to do is to list only the values you want. And you can do this in several ways. An example of allowed listing is basically like a dropdown, right? If you are inputting a date, sometimes you'll find that you get a dropdown with the months of the year. That's an allow list. You're saying, hey, I allow these 12 values, the 12 months of the year. Those are the only ones you're allowed to put in this field. Or, any kind of a picker, really. Dropdowns are a great example of that. You can do this with regex as well. You can say like, hey, I only want to allow, the 26 letters of the alphabet, and then this additional library of, letters with special characters, tildes, accents, that kind of thing. Or very specific punctuation marks. It is more difficult when you get into things like free text. And so that's kind of where sanitization is going to come in more into play. So if you have like a pure free text field where you technically want them to have a lot of freedom to answer as much as they want, it can be as long as it wants, that's when things can get dangerous. But you can control for that more with our other weapon in this battle here, which is sanitization. So with sanitization, you are altering data to ensure it conforms to the requirements of the application. So the data is first validated. We're saying, all right, here's what the users are allowed to pass into our application. And then sanitization is what happens after. So we have the data now. We have the data now. How do we make sure it's safe? It's not going to hurt us in our application. So what we can do with that data then is normalize it. Essentially, making it conform. We want to make sure it conforms to the requirements of our application, whatever those are. We can do that in a few different ways. We can remove some characters. An example of this would be white space, right? So many times in my job anyway, I don't know about you all, so many times I find that I have these entries in my database and they just have random white space, just on one side, on the other. There's those weird invisible spaces that you get sometimes you have to figure out. So yeah, that's an example of normalizing when we're trimming our white space on either side. You might replace characters, right? You can replace characters. An example of that would be, now I don't want to start a flame war here, but maybe you're replacing spaces with tabs on some indents or things like that. I'm a tab person. I don't know. I know people have, yeah, all right. There's one supporter there. People have opinions, I know, but that's an example, right? You don't want a mixture of spaces and tabs. You want to pick one or the other. So you're normalizing your data. You could also encode that data, right? Let's say, sometimes removing characters can be destructive. If you want to say, I'm going to remove dashes, I'm going to sanitize that, then again, you're taking away from that person's name. That's going to make your data inaccurate if you're removing characters entirely. So what you could do instead is you could just encode them, right? Think about URLs. How many times have you entered a URL, in plain text, and then when it actually executes, like a bunch of the characters are replaced with like ampersands and numbers and all that type of thing. All those characters are being encoded because they're not valid to be present in a URL. That's an example of data normalization. It's not getting rid of anything. It's just encoding those characters. And if at some point you needed that plain text URL back, you could just unencode them and you would have what you entered, right? So you can encode them. We can also escape characters. This is something that I've done quite a bit, which is where you're still preserving the original characters. You're just making sure that the target system doesn't think there's something that it has to deal with, right? Something that it has to execute, something that it has to work with, right? It's like it's not going to treat it like a command. It's just going to treat it like a thing that exists. It's going to skip right over it, and it's just going to say like, okay, I don't see this at all. I'm just going to keep on trucking, right? So yeah, sometimes we want to keep those characters, just leave them as is. We can escape them. Most databases have the ability to escape characters. You'll find this a lot with things like escaping single quotes or escaping double quotes in a database. You might escape them with more quotes, and then you get like a wonderful chain of quotes, and it's really confusing. But there's a lot of different ways you can do that. Sometimes it's with a slash, other options there. So you have a lot of different options for sanitization as well. Now, another thing you want to do, and I'll admit I'm guilty of maybe not doing this as much as I should in my own applications, is that you want to sanitize again each time a trust barrier is passed. So what do I mean by a trust barrier? So a trust barrier essentially means a layer within the application where more logic is going to be executed, right? So you've got your front end, you've got your form. So data passes in. There's probably some client-side scripts that are running, doing stuff. You want to sanitize before those scripts get executed. You want to make sure that data is safe. Then it gets passed to another layer. Maybe it goes into your server, you got some controllers going on, and different logic is going to run. And maybe it's on a different platform. Maybe it's in a different language, right? And so it could have different rules. And so you want to make sure that the data is safe for that layer as well. And then maybe it goes to the database. So before it goes to the database, you want to make sure that it's safe again. So maybe you sanitize again. And it's going to sit in the database for a while, and then you're going to retrieve it. And you're going to do more logic before you display it to the user, right? When you retrieve it, you're going to query it, display it to the user. So you want to sanitize again. Another reason for sanitizing on retrieval is that maybe that data has been in your database for 5 years. And your rules have changed since then. Your interface has changed since then. You've added additional sanitization on incoming data. But that data was already in your database. It hasn't been touched. So you're going to retrieve it again, sanitize again, and make sure it's safe. It's not going to do anything you don't expect. So how do we actually do this? I'm giving you all the things you should do. So how do we actually do it? So you have a lot of different options here. You'll see some QR codes there. I'll talk about those in a second. But in general, you want to understand the use case for each data element you are bringing in. Like I said before, you shouldn't just be collecting data for the heck of it. I know that's tempting sometimes, but we shouldn't be, because we don't know what that data is or how it's going to be used. So we should know the use case for each database, for each data element. Where and how does each user input travel within the application? Is it bouncing around through multiple controllers, getting written to the database, and then being retrieved by an entirely different application? Do you know? Where is it going? Where does that data live? Where is it going? That's going to inform you. That's going to inform your sanitization rules and what type of data you accept in the first place. Also, please don't reinvent the wheel. I know it's tempting to, try to build your own regex because we like to get fancy. Is anybody afraid of regex? Yeah, lots of us are afraid of regex, right? Yeah, I mean, hey, me too. Regex is scary. So yeah, don't try to do your own. This problem has been around for a while. That comic I showed you was from 2007. People have had a lot of time to try to solve these problems, and they've built a lot of wonderful tools that can help us with validating and sanitizing data. So first off, just build your forms well. I know just build your forms well. Be mindful of the attributes. Assign the right attributes to the right forms. Use the right form type in the first place. Just build your forms well. Use what's built into HTML. If you're even using HTML. And then there's a lot of wonderful libraries out there, things like DOM Purify, a bunch more. There's also the wonderful Open Worldwide Application Security Project. That is a marvelous organization that just is trying to help you make your application safer and more secure. These 3 QR codes up here, please do scan them. They are the OWASP cheat sheets for things like input validation, SQL injection, cross-site scripting prevention. They are, I promise, it's not dense documentation. These are literally the Cliffs Notes. These are the cheat sheets. They're like one-pagers on all the things you can do to make your application safer, do better validation, do better sanitization, scan those. Also, control script execution and database access. A lot of databases have the ability to prevent execution of bad stuff, right? Assign the appropriate user roles to your applications. Make sure that people who aren't allowed to execute stuff aren't allowed to execute stuff. That school administrator should never have been allowed to run a drop table statement against the database. It should not have happened. So that app probably shouldn't have had the ability to do that in the first place. Only an admin should be able to run destructive observations or executions. Okay, I'm out of time, but just make sure that you're sanitizing, you're validating. Please give your data engineers good data. We will thank you. All right. Thank you, everyone. Thank you.